We have a few different theorems around chords, radiuses and tangents. So just as a reminder, if we have a chord, we have our circle, a chord is coming across part of that circle. A radius is obviously from the center of the circle to the edge, and a tangent is a line that sweeps past the circle and touches it in exactly one point only. So we're going to be using those three different things in this video. So the first one is that if I draw any chord, so for example here, could be anywhere, this was my chord, and I draw the radius on and join them together, so to the center of the circle, they will always meet at 90 degrees. And they will meet in the middle, which means that these two distances either side are the same length. And that's the chord bisector theorem. So it cuts it exactly in half, and it meets at 90 degrees where I go to the radius. The second theorem is the angle between a tangent and a radius is exactly 90 degrees. So I have my tangent here coming across, and it touches the circle at exactly one point only. And where the radius meets that tangent at the same point, it will always meet at 90 degrees. And then moving on from that rule and just developing it a little bit further, if I had that happening in two different places and then the two tangents meet one another, so I have the first tangent and the second tangent and they're meeting here, they will always be equal distance. So the length of these lines from the point that the radius touches to the point where they meet will be exactly the same length, this part and this part. So using that, on this particular question, we know that if this is the center of my circle, this is a radius, and it meets my tangent at 90 degrees. So therefore, I could draw on here 90 degrees of where these two meet. Even though I'm not asked for that, it's something that's really useful to label early on. We can then see that we've got a triangle, and we know that a triangle adds together to make 180 degrees, and therefore 180 minus the 80, minus the 90, minus the 36 is going to give me x, which is 54 degrees. I can also see that I have a diameter here, and it forms an angle in a semicircle. And we know that when that happens, we have a 90-degree angle at the circumference. So y is therefore 90 degrees. So again, I can do 180, so using that triangle, minus the 90 minus the 30, and that's going to give me z, which is 60 degrees.